Hello, everyone. My name is Ram Vennam. I'm a solutions architect at solo.io. And over the last 5 years, we've helped countless organizations improve their cloud native application networking. And in those 5 years, I've noticed a lot of anti-patterns that organizations adopt over time. And in this video, we're going to break those down and then contrast it with the right way of doing things. So what I have here is a couple of Kubernetes clusters on the bottom. There's a cluster here and there's a cluster here. And typically when traffic is entering these clusters, organizations send that traffic through some sort of of an API gateway, right? So this is, let's say this is like a legacy API gateway that runs outside of the Kubernetes cluster. And this gateway does things like authentication, rate limiting, and direction of traffic depending on where it needs to go. So immediately right off the bat here, we start seeing some problems, right? There's Kubernetes clusters that run your applications and developers deploying our apps here. And then another team owns the API gateway and typically programs them using proprietary API. So this is not Kubernetes native configuration. It is some sort of ClickOps UI or proprietary API that is custom to that gateway. So another team that owns this. So every time a new application comes up, that team has to rely on ticket ops systems to interact with the gateway team to open up this new configuration or open up this new route that gets to their application. So two different teams have to get involved here every time a route changes. So what they do is, what they don't have is self-service. So again, developers don't have self-service because they're relying on an external team to route traffic to their applications. Now, when this application wants to route to a different application, if it's in the clusters, typically that starts off by going direct communication to that cluster. And then if it needs to go to an application that's running in a different cluster, a different environment, et cetera, they have to hairpin that traffic through the gateway to get back over there. Over time, what we see is that whether traffic is coming from another cluster or coming from the same cluster, it needs the same type of gateway policies applied to it, things like authentication and rate limiting. So we can't do this direct communication anymore if the application itself doesn't have that logic to be able to do it. So what we see teams do is instead of going direct, they will actually hairpin that traffic around the API gateway, even in the same cluster, right? So there's a lot of hairpinning that's going on here. So a lot of things start breaking down here. For example, this API gateway, it doesn't know the internals of Kubernetes. It doesn't know pods, IPs, how Kubernetes is doing its health checks, etc. It's Kubernetes blind. So it's not able to give you the advanced features that developers need to do things like canary routing, session affinity, etc. So it's Kubernetes blind. From an observability perspective, when things are not working, trying to debug exactly where stuff is broken is a nightmare because you have multiple hops and multiple hairpinnings going on and everything's being routed to the gateway. So you don't have this end-to-end observability. But what's more important is that you also don't have end-to-end identity. You don't have security because you're breaking up, you're losing the identity of the caller every time you hairpin around a gateway. So if we break that down, let's say this application wants to talk to this app. When it wants to do that, it has to call the API gateway directly or indirectly. So I've seen users do custom libraries, or use an external service discovery mechanism to determine where the app is and register that endpoint, that API gateway endpoint. So there's this hairpinning. For this hairpinning to happen, we're relying on service discovery. But we're also relying on certificates and security so that this traffic from here to here is encrypted. So for you to get TLS over here, your application now has to deal with certificates to be able to do this communication. And then the API gateway gets that traffic, it terminates that connection, reinitiates a new connection from here to here. Now that could be, again, TLS, or a lot of organizations just rely on plain text for that traffic. So you have this broken identity, which means you cannot enforce zero trust, right? You cannot create a policy that says only this app is allowed to talk to this app if that policy now has to depend on this intermediary in between that is breaking up the identity. We also talked about hairpinning of traffic, every single traffic around the API gateway. So that adds extra latency, that reduces your performance, but more importantly, it adds cost. Typically, these API gateways, they're charged by the amount of their call volume. So if you're routing all east-west traffic, all internal traffic through the API gateway, there's a cost factor to it, both in terms of price and performance. And worst of all is this now is a single point of failure for your system. If this API gateway were to go down, or if your external service discovery mechanism that is telling all the applications what are the API gateway endpoints for all the other applications, now you've introduced that single point of failure where you're relying on the API gateway and service discovery to route all traffic, whether it's north, south, or east, west. So these are the main problems we see with organizations that have modernized their application delivery and deployment, but they've not modernized their networking, and they're relying on legacy style networking to route traffic to where it needs to go. So next, let's take a look at the best practices that we see and how we help organizations move and adopt cloud native networking.